I'm going to be using geometric area to solve for the definite integral. And the equation I'm going to be using is to integrate between -2 to 2 of the function -3 minus the square root of 4 minus 3x squared dx. The first step in a geometric area problem is to draw our graph. And then we'll mark out our two x's, which is going to be -2 and 2. And we know it's going to go down to -3, so 1, 2, 3. And our first points are going to be at -2, -3, and 2, -3. And our last point, because the square root is negative, it's going to go down, so 1, 2. And that'll be our last point, and we'll draw out our semicircle. Now, for this one, we're going to have two different area equations. We're going to have a rectangle to help us, because we have to solve for everything underneath the x-axis and the graph. And then we're going to have to solve for the rectangle and solve for the semicircle. So the area of the rectangle is going to equal the distance of our x, which is 4, and then our how far we went down, which is 3, and that's going to equal 12, but it's going to be negative since it's below the x-axis. And then the area of our semicircle is going to equal 1/2 pi r squared, which is going to be 3 squared, and that's going to equal 9 pi over 2, which is also negative because it's below the x-axis. Now we're going to add these two, so -12 plus -9 pi over 2, and that's going to get us, our definite integral is going to equal -12 minus 9 pi over 2, and that's going to be the net. Now if the problem asks for the total, what you would do is you would take the absolute value of your two values, or if you only had one, then you take the absolute value. So for us it would be -12 plus the absolute value of -9 pi over 2. Then that will get us 12 plus 9 pi over 2 di equals, is going to be our total.